Good morning. I'm going to quickly go through like a little mini lesson around number 1 from the Unit 5 post assessment, which has our students multiplying a whole number by a fraction. So I'm going to go through a quick mini lesson that hopefully will help students understand it a little bit better. So I'm going to start with the problem 3/5 plus 3/5 plus 3/5 plus 3/5 plus 3/5 plus 3/5. We know by now that if we had to add these fractions together, that we do not add the denominators, that when we're adding fifths, the fifths is simply the name of the part. But we do know that it would be the 3 that would be added. We'd be adding 3 plus 3 plus 3 plus 3 plus 3 plus 3. And since that's repeated, we could solve that with multiplication instead. There are 6 3's, so then I know that I could do 6 times 3, and that would give me 18 fifths. Now, the reason I'm starting with a problem like this is because this problem right here could be represented, since it's adding the same number over and over, we could represent this as a multiplication problem. We are multiplying 3/5 6 times. And so then one of the questions that kids keep having is they're wondering, am I supposed to multiply the 3 by 6? Am I supposed to multiply the 5 by 6? Well, if we remember that this represents this repeated addition, then we should know that it's only the number of parts that we are adding 6 times. So the 3 times 6 would give us 18 parts, but the part size doesn't change. Those are still 18 fifths. And then just as a kind of a quick reminder, 18 fifths can be renamed by using 18 divided by 5. 18 divided by 5 would give us 3, and then there would be a remaining 3 fifths. So let me go ahead and flip this over, and now let's kind of go the reverse process. So now we have a problem that is 4 times 7 tenths. And what we need to remember is that this problem means that we are adding 7 tenths 4 times. So if I were to write that out down here, 7 tenths, 7 tenths, 7 tenths, and 7 tenths, again, what we know is that we'd be adding the 7 4 times, but we would be leaving the 10 as 10 for our denominator. So up here, if I were to show that, it'd be 4 times 7 equals 28, but that those 28 parts are still tenths. And if I then go ahead and divide 28 by 10, that would leave us with 2 and 8 tenths. So I'm going to go ahead and put just one more example up here just to kind of show you, but I hope this helps. These are 2 problems that have already been completed. So if I was going to do 6 times 3/8, that means that I'm adding 3/8 6 times, and it's really only the 3 that needs to be added. So 3 times 6 is going to give me 18, and the parts are still eighths. 18 divided by 8 gives me 2 and 2/8. 24 times 5 6 means we are adding 5 6 24 times, which means that we would have to end up adding 5 parts plus 5 parts plus 5 parts 24 times. So if I do 5 times 24, that gives me 120 parts, and those parts are still sixths, and 120 divided by 6 equals 20. I hope this helps.